Space frontiersmen, welcome back to our channel where we dive deep into the cosmos and explore the latest in space, science, and technology. Saturn, the sixth planet from the Sun, is perhaps best known for its stunning and complex ring system. These rings have fascinated astronomers and the general public alike for centuries. But what exactly are these rings made of? How did they form? And what does the future hold for them? Today, we'll explore the captivating story of Saturn's rings, from their formation to their eventual fate. Before we go into our explanation, we have a very small request. If you like our content, please support us by subscribing to our channel. It's a small click for you, but for us, it means a lot. Thank you. Let's begin. First, let's talk about what Saturn's rings are made of. The rings are primarily composed of countless small particles, ranging in size from tiny grains of ice to chunks as large as mountains. These particles are mostly water ice with a sprinkling of rocky material. The rings are incredibly thin relative to their vast width, measuring only about 10 meters to 1 kilometer thick, but stretching out over 280,000 kilometers from the planet's center. The rings are divided into several main sections, named alphabetically in the order they were discovered: D, C, B, A, F, G, and E rings. The B and A rings are the most prominent and are separated by a gap known as the Cassini division, which is about 4,800 kilometers wide. Each of these rings is further subdivided into thousands of smaller ringlets, creating a complex and dynamic structure. Now let's delve into the formation of these rings. There are two main theories about how Saturn's rings came to be. The first theory suggests that the rings are remnants of a moon that was shattered by a collision with a comet or asteroid. This catastrophic event would have occurred relatively recently in the history of the solar system, perhaps within the last 100 million years. The debris from this collision would have spread out and formed the rings we see today. The second theory posits that the rings are made of material left over from the early solar system. According to this idea, the rings could be composed of icy particles that never coalesced into a moon due to Saturn's strong gravitational forces. These particles would have been captured by Saturn's gravity and gradually formed the rings over billions of years. Recent data from the Cassini spacecraft, which orbited Saturn from 2004 to 2017, has provided valuable insights into the age and origin of the rings. Cassini's observations suggest that the rings are relatively young, likely less than 100 million years old. This supports the idea that the rings may have formed from the remnants of a shattered moon or a captured comet. But how do these rings maintain their structure and stability? The answer lies in the complex interplay of gravitational forces. Saturn's moons play a crucial role in shaping and maintaining the rings. For example, the moon Mimas is responsible for the Cassini division, as its gravitational influence creates a gap in the rings. Other moons, known as shepherd moons, help to confine and shape the narrow F ring. These moons, such as Prometheus and Pandora, exert gravitational forces that keep the ring particles in place, preventing them from spreading out and dissipating. Saturn's rings are not static, they are dynamic and constantly changing. The particles within the rings are in constant motion, colliding and interacting with one another. These interactions can create waves and spiral patterns within the rings, which can be observed from Earth and by spacecraft like Cassini. Additionally, the rings are influenced by Saturn's magnetic field, which can cause particles to become electrically charged and interact with the planet's magnetosphere. Now let's consider the future of Saturn's rings. While they are a breathtaking feature of our solar system, they are not permanent. Over time, the rings are gradually losing material. This process, known as ring rain, occurs as particles from the rings are pulled into Saturn's atmosphere by its gravity. The particles then vaporize and become part of the planet's atmosphere. Cassini's observations have shown that this process is happening more quickly than previously thought, with an estimated 10,000 kilograms of ring material falling into Saturn every second. Given this rate of loss, scientists estimate that Saturn's rings could disappear within the next 100 to 300 million years. While this may seem like a long time, it is relatively short on a cosmic scale. Eventually, the rings will become so thin and diffuse that they will no longer be visible from Earth. In addition to ring rain, the rings are also affected by the gravitational influence of Saturn's moons. Over time, these interactions can cause the rings to spread out and lose their distinct structure. Some of the ring material may even be captured by the moons, adding to their mass and altering their orbits. Despite their eventual fate, Saturn's rings continue to be a source of wonder and scientific discovery. They provide a unique laboratory for studying the processes that shape planetary rings and the dynamics of our solar system. The data collected by the Cassini spacecraft has revolutionized our understanding of these magnificent structures and will continue to inform future research. In conclusion, Saturn's rings are a stunning and dynamic feature of our solar system. Composed primarily of water ice, they are relatively young and may have formed from the remnants of a shattered moon or a captured comet. The rings are shaped and maintained by the gravitational forces of Saturn's moons, but they are gradually losing material through a process known as ring rain. While the rings will eventually disappear, they remain a captivating subject of study and a testament to the beauty and complexity of our solar system. Thank you for joining us on this journey through the rings of Saturn. We hope you've gained a deeper appreciation for these incredible structures and the forces that shape them. Until next time, keep looking up and marveling at the wonders of the cosmos. Thanks for joining us today, and don't forget to like, subscribe, and hit the bell icon to stay updated on all things space and science.